Hello students, so this is your lecture 19, memory interfacing. So till now we have covered the first section of this 8086 microprocessor. So first section is what about the architecture. About the architecture, pin diagram and different signals. And second part is what instruction set. Instruction sets. So there are different type of instruction that we have already covered. And now we are going to start the main important part, that is what interfacing part, and third part is what interfacing. Okay, so section B, this is the part of your section B. So architecture and pin diagram signals we have already covered, and next part is what instruction set, and now third one important part is what interfacing. So in interfacing, first we are going to start the memory interfacing. How we will connect or how we will interface the memory to the 8086 microprocessor. So let's start. So in your first lecture we have already covered that the basic block diagram of the microcomputer or computer is what this is microprocessor, and this is what memory. Memory is required to store the data and to access the data, and this is what input output. So whenever we want to provide some input data, so we will use input devices, and sometimes we want to display the out response, so we will use output devices. So this is called input output devices, and to store the data we require memory. Okay, so sometimes we want to store the data in temporary basis or permanently, so we require to store the data we required memory. So without connecting the without interfacing the memory or input output device, so microprocessor cannot perform its all tasks. Okay, so basically microprocessor needs to interface the memory and input output devices. So in this section or in this lecture we will discuss about the interfacing, how to connect the memory or input output devices. So first we will start the memory interfacing. Memory interfacing. So as we have earlier discussed that without interfacing the memory or input output devices, microprocessor cannot perform any operations. Okay. Although some internal operations are there, those are being performed. Those can be performed without the help of peripheral devices. But to perform the all task or microprocessor requires the memory or input output devices. So you can uh, divide the memory into two forms. So memory is what ROM, read only memory. Only we can read operation can be performed in this ROM. Okay, and this is what read write memory or random access memory, that is called what RAM. So RAM can be divided into two form, that is what static. Okay, we have already covered this types of the memory in your fundamental of the computer subject or in digital electronics subject. So RAM can be divided like static RAM, SRAM, that is called what, SRAM, or dynamic RAM. So the RAM is also called read write memory. Okay, so this is also called read write memory. So we can read it or we can write it. But in case of ROM is what we can only read the memory. So ROM को आप divide कर सकते हो. Basically ROM is what, PROM, programmable ROM, and EPROM, and this is what, electrically erasable PROM, programmable ROM. Okay, so this is also erasable. So, but in this case, we use the UV rays to erase the content of this memory, and here we use the electrical signal to erase the content of this memory. Okay, so suppose 1 KB memory. So, what do you mean by this 1 KB memory? So, 1 KB memory means 1024 into 8, where this 1024 is what? So this is what, number of memory location. Number of memory locations. And this 8 is what? Number of bits in each memory location. Okay. So this 1024 is denoting what? The number of the memory location. So 1024, there are 1024 memory location, and each memory location is having 8 bits. Okay. And similarly, suppose if we have 8 cross 4 memory. Suppose if you are having 8 cross 4. So what do you mean by this? Suppose this is 8 cross 4 memory. So this 8 is denoting what? Number of memory locations. Number of memory location. So there are 8 memory locations, and each memory location is having 4 bit data. So this is what? Number of bits. Number of bits in each memory location. Okay, so suppose this can be defined like this. So this is the memory. So there are 8 memory location. So suppose this is 1, 2, 3. So this is 1 memory location, 2 memory location, 3rd memory location, and this is 4th, and this is 5th, 6th, 7th, or 8th memory location. Okay, so these are the 8 memory location, and each memory location is having 4 bit data. So suppose this is what, 1, 2, 3, and 4. 4 memory locations. These are the memory locations on which the data, it means each memory location is having 4 bit data. This is 4 bit. So this is 4 bit data, and so on. So this is 4 bit data. It may be 0, 1, 1, 0, 0, 1. Okay. So each memory location is having 4 bit data. So this 8 into 4, again we can write this 8 into 4, and this 8 can be represented like this, 2 to the power 3, and this 3 is what it means. The 3 bits are required. How many bits are required to address these memory locations? So 3 bits are required to address the 3 bit required to address the 8 memory location. Okay, so there are 8 memory location, and to provide or to allocate this memory location, we require the 3 bits. So 3 bits required to point out the address of this 8 memory locations. Okay, so combination of each bits will represent the particular each memory location. So suppose if these bits are 000, it means this is indicating the first memory location, and suppose this is 001, so this is denoting the second memory location, and this is 010, then third memory location, 011, then fourth memory location, and so on. This is what 111. Okay, so it means each combination of 3 bits is basically representing the or to pointing out the each memory location. Then how to perform, how to select this input combination, how to select this the memory location. So these on the based on the selection of the 3 bits, we can select the particular memory location. But how to select these bits? So this memory location are being selected with the help of decoder. Okay, so this task is being performed by the decoder. So it means, so the first block of any memory block is what? Decoder. So with the help of decoder, we basically, with the help of the decoder, we can select the different memory locations. So there are 3 bits. So decoder जो यहाँ पे use होगा, that will be of what? 3 into 8 decoder. 3 into 8 decoder. So there will be what? 3 inputs. So this is input 1, input 2, input 3. 3 input. So there will be what? Output. This is output 0, and so on. Suppose this is output 7. So there will be what? 8 outputs. Okay. So with the help of 3 bits, we can select the 8 memory location. 8 memory location. Okay.
So this is the basic block diagram of the memory. So you can see, so if the memory size of the memory is being given by 2 to the power n cross m, then where n is what the number of address lines. So the number of address lines, so at the input side there is what? Row decoder, and there will be also the column decoder. So decoder is the first building block of the any memory. So what is decoder is doing? So decoder is uh, generating the 2 to the power n lines. Okay, so to point out the location of the memory, we will use the decoder. Okay, and m is what? M bits is what? Representing the number of the bits that is stored at the each memory location, or This is also representing the data lines, and at the input and output side there is buffer. For the input there will be input buffer, and for the output there will be output buffer. So this is the basic this is all about the basic block diagram of the memory.
So first block of any memory is what? Decoder. So again take that example 8 cross 4, 8 cross 4 memory. So it may be RAM or ROM. So 8 cross 4, it means 8 can be represented like this, 2 to the power 3. So 3 bits required to address the 8 memory location, and this is what? 8 memory locations are there. Okay. To address this 8 memory location, we require the 3 bits. So 3 bits are required to allocate or to address these 8 memory locations, and on the based on the selection of these 3 bits or combination of the 3 bits, we can select the particular memory locations. So this task is being performed by the decoder. So suppose here decoder will be 3 cross 8 decoder, 3 cross 8 decoder. If suppose input combination is what? This is input combination. Suppose this is I0, I1 or I2. If this is I0, I1 or I2. So if suppose I0, I1, I2 is 0, 0, then this is output is Y. So Y0 will be selected. If this is 0, 0, 1, then Y1 will be selected, and this is 0, 1, 0, then Y2 will be selected. So this is the basic operation of the 3 cross 8. So similarly, so there are the 8 memory locations. So if the input is 0, 0, 0, then 0th memory location will be, this is suppose 0th memory location. So 0th memory location will be selected, and 0, 0, 0. If this is 0, 0, 1, then this first memory location will be selected, and now again suppose this is 0, 1, 0, then second memory location will be selected, and similarly, and suppose if this is 1, 1, 1, this is 1, 1, 1, then 7th memory location will be selected like this. Okay. So so suppose 8 cross 4 memory, 8 cross 4 memory location, this is memory, and this may be what? RAM and ROM. We have not specified yet that this is RAM or ROM. Okay, this may be RAM, this may be ROM. Okay, but concept remains same. And the first block of any memory location will be what? Decoder. So decoder can be represented like this. So this will be what? Decoder, or in this case there will be 3 into 8 decoder, and 3 inputs are there. So let input is what? A0, A1 and A2, and these are called address lines. Address lines. So address lines are being identified by how many bits are required to address the memory locations, and these are being identified by this, by like this, 2 to the power 3, then 3 bits are required. It means there will be 3 address lines. Okay, so this 8 is representing what? The number of memory location, or what? 2 to the power 3. So this 3 is representing what? The number of bits required to address this 8 locations, and this 3 is also what? Address lines, and this 4 is also called the data lines. This is what? Data lines. or how many OR gate will be there. Okay, I will explain you. So 3 cross 8, it means A0, A1, A2 are inputs, and this is also called address lines. So this is what Y0, this is Y1, and up to Y7. Okay, so you can see Y0 can be denoted as like this: A0 bar, A1 bar, A2 bar, and Y1 can be represented by A0, A1 bar, and A2 bar. Similarly, Y7 can be A2, A1, or A0. Okay, and data lines are being represented by OR gates. So like this. So this will be what D0. So this there are 4 data lines. So data lines are being represented by like OR gates. So like this D0, and this is what D1, and this is what D2 and D3. So like this, the data line can be represented. So till now we have discussed about the basics of the memory. Okay, we have already covered the basics of the memory. What is memory? Memory can be classified into RAM or ROM. Okay, so basics of the memory. Then we have already discussed about the address lines. What is address line and data lines? So how can we identify that how many address lines are there, how many data lines are there, how many OR gates are there, and what do you mean by this 8 cross 4 memory or 16 cross 2 memory, or you can say this is how, what is the meaning of this 1 kV, 8 kV. Okay, now we will design the 8 cross 4 ROM. How the ROM are being designed? 8 cross 4 ROM. How to design? So the basic meaning of 8 cross 4 is what to, how many address lines are there. So you can see that there are 3 address lines are there. 3 address lines are there. So address line can be classified like this. This is A naught, A1, or A2. So you can say A naught is what LSB, and A2 is what MSB. So this is what MSB, and this is LSB. And how many data lines are there? 4 data lines are there. Okay, so data line can be represented like this: D0, D1, D2, and D3. Or we can say how many OR gates are there. So you can see that there are 4 OR gates are there. Okay, and how many locations are there? So you can say 8 locations are there. So how many bits are required to address this 8 memory locations? So 3 bits are basically required. Okay, and 3 address lines are required. So first block of any memory location is what first block of any memory is what decoder. So this is what decoder. Okay, so decoder 3 into 8 decoder, there will be 3 into 8 decoder. So you can see this is what A naught, A1, and A2. So this is what LSB, and this is what MSB. Okay, and one enable signal is there, that is what enable. So whenever enable is 1, so suppose this is active high. If it is active high, then it means enable. For the normal operation of this decoder, we required always E is equal to 1. So this is what enable signal. Or whenever this is active low, so it means we required E is equal to 0. Okay, so this is what Y0, this is Y1, this is Y2, Y3, Y4, Y5, Y6 and Y7. Okay, so this is Y0, Y1, Y2, Y3, Y4, Y5, Y6 and Y7. So this is the these are the 8 outputs. Okay, so 8 cross 4, so 8 cross 4 can be represented like this. So 8 cross 4 memory ROM will be like this. Suppose this is what 0 0 0, so this is what A node, A1 or A2. Okay, and suppose this is 0 0 1, and this is what 0 1 0, again this is what 0 1 1, and this is what 1 0 0, and this is what 1 0 1, and this is what 1 1 0 and 1 1. Okay, so this is A node, this is A1 or this is A2, and similarly there are 8 memory locations. So you can say there are 8 memory locations, and each memory location is having 4 bit data. So D0, D1, D2 and D3. Suppose the memory locations there, those are being pointed out by 0 0 0, so those are having 0 0 1 1 data. Similarly, suppose this is having 0 1 0 or 0, and suppose this is having 0 1 1 0, and suppose this is having 0 1 0 0, and again this is having 1 0 0 0, and this is 1 1 0 0, and this is 0 1 0 0, and this is 1 1 1 0. Okay, so this is 8 cross 4 ROM. And how to design it? Suppose whenever A node, A2, A1 node, A1 and A2 is 0 0 0. So suppose this is 0, this is 0 and this is 0. So only Y node will be 1, and rest of this Y1, Y2, Y3, Y4, Y6, Y7 will be what 0 0 0. So it means इस लाइन पे क्या होगा, बेसिकली आपके पास में इस लाइन पे आपको मिलेगा 1 और बाकी सब पे आपको क्या मिलेगा 0 0 0 0 0 मिलेगा. ओके, सो इट मींस फर्स्ट मेमोरी लोकेशन विल बी सिलेक्टेड 0 0 0. सो इस लोकेशन पे डेटा कौन सा स्टोर है 0 0 1 1. इट मींस डी नोट पे आपका 1 अवेलेबल है, D1 पे सॉरी दिस इज D1. ओके, सो D नोट पे आपका अवेलेबल है 1, D1 पे 1, D नोट पे 0 एंड D3 पे आपका 0. So there will be 4 OR gates for the D node, D1, D2 and D3. So D node, D1, D2, D3 कुछ इस तरह से डिफाइन होंगे बेसिकली कि so there will be 4 OR gate. So this is what D node, and this is what D1, and this is what D2, and this is what D3. Right? Okay, and This D1 D node, D1 D node, D3 are being connected by all these lines. Okay, and this is also connected by like this. Okay, and this is also connected by like this. Okay, so D node, D1, D2 and D3. So there is a concept of fuse. Fuse is intact or blown. So basically, what we are going to discuss, we are going to design this 8x4 memory. So how it will work? So suppose A node, A1 and A2, A node, A1, A2, all are 0, 0, 0, A 0, 0, 0. So it means this memory location will be selected. Okay, 0, both A node, A1, A2, all are 0. So it means this memory location will be selected. So at this memory location, the data there, those are 4-bit data will be saved, and this data is what 0011. It means D node पे आपके पास में 1 है, D1 पे 1 है, D2 and D3 पे क्या है 1. So it means Y0 पे 1 अवेलेबल होगा, बाकी Y1, Y2, Y3, Y4, Y5, Y6, Y7 पे 0 अवेलेबल होगा. ओके, सो D नोट पे आपको लेके आना है 1, देन D1 पे आपको लेके आना है 1, देन D2 एंड D3 पे लेके आना है 0, 0. तो कैसे लेके आएंगे बेसिकली? सो देयर इज द कंसेप्ट ऑफ फ्यूज. सो देयर इज ए कंसेप्ट ऑफ फ्यूज. सो I can write this. So there is a concept of fuse. So if there is, this sign is representing what? Intact. It means don't break, and this sign is representing the blown. It means connection blown, break the connection. कनेक्शन अगर आपको ब्रेक अगर शो करना है तो क्रॉस से मैं शो करूंगा. अगर कनेक्शन आपको ब्रेक नहीं करना है, डीबी मतलब डोंट ब्रेक, सो मैं शो करूंगा प्लस. सो आपको इस पूरी की पूरी लाइन वाई नोट पे आपको क्या मिल रहा है? 1 मिल रहा है. तो ये लाइन बेसिकली D3, D2, D1, D नोट सबसे कनेक्टेड है. इट मींस D नोट पे आपको 1 मिलेगा, D1 पे 1 मिलेगा, D2 पे भी 1 मिलेगा, D3 पे भी 1 मिलेगा, एंड रेस्ट साइड 0 हो. Y1, Y2, Y3, Y4, Y6, Y7 सारे के सारे 0 है. ये OR गेट कुछ इस तरह से बना हुआ है. बेसिकली OR गेट को आप कुछ इस तरह से बना सकते हो. OR गेट कुछ इस तरह से बना हुआ है. आपके पास में यहाँ पे आपको मिल रहा है D नोट, और ये D नोट पे आपको कनेक्टेड है यहाँ पे Y नोट से लेके Y7. 8 इनपुट OR गेट है बेसिकली. और मैंने इसको रिप्रेजेंट किया है सिंगल लाइन से. ठीक है, दिस इज 8 इनपुट OR गेट. So similarly, this is 8 input, this is 8 input, 8 input and 8 input. So Y naught is 1, so it means Y naught is also connected to D3, D2, D1 and D naught. So it means all D naught, D1, D2, D3 will be what? 1, 1, 1, 1. But for this memory location, only D naught and D1 are 1, and D2 and D3 is what? 0, 0. So we will use the concept of the fuse. So wherever we require the connection, so we will intact them, and if we don't require connection, or when we feel if we want to break the connection, then we will use this sign. So this Y naught, at this Y naught line 1 is being represented. So we required only D node, we required the 1 at D node and D1, but at this D2 and D3 we want to break the connection. So what we will do? So we will use this sign. So this sign basically represent the what? Break the connection, blown, break the connection, and intact. So this is intact. Okay, and again suppose for the Y1, so at this condition at D node D1 पे 1 अवेलेबल होगा, D2 एंड D3 पे क्या अवेलेबल होगा? 0 अवेलेबल होगा. Again, suppose input is, so input is what, 0 0 1. So A2 is equal to what, 0. Suppose I want to select this. A2 is 0, A1 is 0 and A0 is 1. So this A0 is 1, A1 is 0. Then again, which memory location will be selected? This memory location will be selected. It means at the Y1 there will be 1, at the Y1 there will be 1, and for the rest output lines there will be what, 0. Okay, so like this, at this Y1 there will be 0, at the Y1 there will be 1, again all will be what, 0 0 0 0 at 0. And simply at this memory location 0 1 0 0 is being stored. It means only D2 line will be what, 1, and rest D0 and D0, D1 and D3 will be what, 0. So we have to break the connection from here and from this point and from this point. Okay, and suppose both A1, A0 and A1, A0, A1 and A2 are 1 1 1. Suppose this is also 1, this is also 1. Then this memory location will be selected, and at this memory location D node will be 0 and all the D1, D2 and D3 will be what, 1. So this will be represented like this. So I want to break the connection from here so that D node will be what, 0, and rest D1, D2 and D3 will be what, 1. So this is the basic concept of what, ROM. So this 8 cross 4 ROM can be represented like this. Eight cross 4 ROM can be represented like this. So there will be what, 3 address lines. So A0 to what, A2, A0 to A2, and there will be what, 4 data lines will be there, 3 address lines and 4 data line will be there. So data line will be what, bidirectional way. So this is what, D0 and this is D3. Okay, so for data line will be there, and one selection signal will be there, or that is what, like a enable signal will be there, and this is what, read only memory. So there will be one more signal, what, RD bar. So this is what, low active signal, read bar signal will be there. So like this we can represent the 8 cross 4 row. So thank you students. So in this lecture we have discussed about the memory, types of memory, and how to design the ROM. So in next lecture we will discuss the how to design the RAM, how to read and write operation are being performed in the RAM. Then later on we will discuss the how the memory are being RAM or ROM are being interfaced with the microprocessor.